Hi everyone, it's Sorkin. Today we have a problem when we are given M2N matrix and we need to return all elements of the matrix in spiral order. So for example, in this case, we need to return 1, 2, 3, 4, 8, and so on. So how are we going to solve this problem? The solution is pretty straightforward. So we are going to maintain 4 variables: left, right, top, and the bottom. So left, right, top, and the bottom. So what is the value for the left is we're starting from the 0. For the top is the same, it's starting from 0. And for the right, it's how many columns we have, right? We have 4 columns, and since it's a 0-based index, we are setting the value to 3. The same for the bottom. So for the bottom, the value is 2 because we have 3 rows and it's a 0-based index. We are taking the value of 2. So now for the implementation wise, what we are going to do here. So first we are going to start with the index 0, 0, right? The first step is we are moving from left to right. We are moving from left to right. So we're moving from left to right and adding all the elements. So we are adding 2, 3, and so on. So at this point, we are at the index 0 and 3, right? 0 and 3. And the next element that we should add is 8. So now we need to move from top to bottom. So we need to move from top to bottom, and the next element we have already added 4, we need to add 8. To add 8, what we do is we are incrementing top. So we are incrementing top here. So our top now is equals to, our top is now equals to 1. So we are moving, so we are adding 1 and so we are adding 1 and 3. So we are adding 2 and 3, right? So the next step is we are moving from top to bottom, right? We are moving from top to bottom. So we move to top to bottom. So we are at the last element. Now what we need to do, we need to move from right to left. So we need to move from right to left. And the next element that we should add is 2 and 2, right? So what it means? It means that we need to decrease our right we need to decrease the value of right. So we are at this point, we are decrementing right, and we are moving from right to left. So we are moving from right to left. So we are visiting 10, right, to 1, and the 2, 0, we are adding that to our result. And the next one is that we should move, so this is our last element on the left, so we should move from bottom to the top. So we should move from bottom to the top, and we need to add 1 and 0, right? So we need to add 1 and 0, which means that we need to decrement bottom. So we need to decrement bottom here. We need to decrement bottom. So the bottom now becomes 1. So we are adding 1 and 0. So that's it, right? So that's the last element because we have already added 1. So the next one is what we need to do. We need to so we are moving the next step is we are moving from bottom to the top. And the next one is we need to add what? 1 and 1, right? So to do that, what we are going to do, so this is the next element to the left, right? So we are incrementing our left. So our left becomes 1, and that's it. These 4 steps we are doing until our left is equals to right and until our top is equals to bottom. We are doing that recursively. So if these conditions are met, then we are returning result that we are getting. First thing that we do here, we are creating a result. And then we are checking if our matrix is empty, then we are returning our empty result right away. If it's not, then we are defining our M and N, which is our how many columns we have and how many rows we have. And as we have seen earlier, we are defining 4 variables: top, bottom, left, and the right. So top is equals to 0, bottom is how many rows we have, -1, because it's 0 based index, and the same for the left is equals to 0, and the right is n -1. So the next step is we are moving, so we are going iteratively and adding our elements to our result until our bottom is less than or equal to our top is less than or equal to our bottom, and the same left is less than or equal to our right. So what we do is, first step is we are moving from left to right, and we are adding the value of our matrix to our result, and we are moving our top. We are incrementing our top, as we have seen earlier. And the next step is we are moving from top to bottom. From top to bottom, again, we are adding our results to our we are adding our values to our results, and we are decrementing right. So the next step is we are moving from right to the left. So first we are checking that if our top is less than or equal to bottom, then we are moving from left to right, from right to left, and we are adding again results. We are adding values to our results, and we are decrementing the bottom. And in the last step, we are checking that if our left is less than and equal to right, then we are moving from bottom to the top, and at the end we are incrementing our left. And once we exit this while loop, we're returning our result. So what's the time and space complexity of this solution? The time complexity is we are visiting every cell, so it's m multiplied by n, and in the space complexity we don't use any extra space, it's a constant of 1. Java implementation is identical. So first thing that we do, we are creating a result, and we are checking our matrix. If our matrix is equals to null, or the length of it is equals to 0, then in that case we are returning our result right away. If not, then we are defining how many rows and how many columns we have, and then we are defining our top, bottom, initializing our top, bottom, left, and the right. So we are moving until our top is less than or equal to our bottom, and our left is less than or equal to our right. So first thing that we do, we are moving from left to right and adding the values to our result and incrementing our top. Then the next step, we are moving from top to bottom and adding the values to our result and decrementing right. At the next step, we are moving from right to left, but first we are checking if our top is less than or equal to our bottom. We are adding values to the result and decrementing our bottom after we at the leftmost cell. As a last step, what we do is we are moving from bottom up, and if first we're checking if our left is less than or equal to right, then we are moving from bottom to up and adding the values to our result. And once we exit this for loop, we are returning our result. And since we are visiting every cell, our time complexity is m to n, and our space complexity is constant because we are not using an extra space. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.